All right, so let's. Everybody can hear me okay and see the screen? I got at least a positive from the chat. Okay, thank you. Oh, and that actually reminded me. Alex had told me after class on Monday, apparently when I originally put the homework assignment up, that was in theory to do this past Monday. I must have missed a week. So I had put the wrong final due date on there. I updated the due date, but some of you had noticed that it wasn't due on Monday, so you didn't do it. Get it submitted. I won't mark it late. Just whatever. So that way the points go through and stuff. But yeah, some of you had submitted it anyways, but just since there was a discrepancy and I definitely had the wrong due date on there, and then I went back and fixed it. Just get it in, and that way, you know, I can get you your points, but I won't mark it late. Okay, so let's take a look at the assignment here. We had kind of gotten everything prepped for reading in our roads last time. So write the code that reads in from our roads text and actually reads the roads using our parse road code that we wrote, and then builds the actual road objects using our new function in town collection. All right, so going into road here, we see that to build a road, we need 2 town pointers and a distance. If we go into main here, we are reminded that if I pass a road string that we looked at last time into parse road, it will give me a pointer to some road parts. All right. And what is a road part? A road part is a collection of 2 town names in strings and then an int distance. And then we added the ability to our town collection where I can pass it the name of a town and it will give me the actual town associated with that name, which then gives me a physical town that I could use to build a road with. All right, makes some sense. It's like, oh, perfect. Okay, so a lot of moving pieces, but hopefully you're kind of following the breadcrumb trail there and seeing how this is working. So let's go ahead and read in from our file here. There are different things from our road strings. So I'm going to go into main CPP. And I'm going to go into what I'm actually going to do here is I'm just going to copy that function. We could write it a little bit more generically, but we already kind of have a mess here. So let's just move on with life. So we're going to have this guy return a array of roads. So that's a road pointer pointers. That is an array of road pointers. Okay, and we're going to do the same thing as we did last time. Where we're going to make one pass through the text file to count how many of those guys we have. I need to remind myself what a town collection was. Okay, we need to do pretty much the same thing with our town collection. Remember, the reason we created our town collection was because we needed a way of storing two different pieces of information around our array of roads, array of towns. We needed to have the array, the pointer to the array, and then we also needed the count. So we're going to do the same thing with our roads. So this guy will return a road collection. And it's going to have a road pointer. We'll call this guy the roads. It'll have our count. Road collection. We'll take in our road pointer. Roads along with the count. It'll set the roads equal to the roads and the count equal to the count. I'm not gonna, I don't think we need to imagine what we might need this guy to do right this second. So right now, he's just gonna be an object for holding those couple of pieces of information. Which means that down here, this function we're in the process of writing, he's no longer gonna return this. He's gonna return a road collection pointer. Even though he's going to be building up an array of roads, he's going to have to keep track of the count first. All right, so same loop as we had before. We're going to go through this file 2 separate times. The first time was we're going to count the number of lines in the file. The second time, we're actually going to read that file in and parse the things out. So the name of my file here is called roads.txt. So we'll get through our count. Okay. Now, once I have, if we're in the else here, that means we're reading in an actual road. So line, I'll just put a comment here. Line holds the string representation of a road. We need to parse it. All right, we wrote this guy last time. Parse road, which will give us a road parts. So I'll create a road parts pointer. The parts is equal to parse road of line. So that'll get me my individual parts of that. Remind ourselves of road parts. We already looked at this once, but just remind ourselves right now. So I have my town 1 name, my town 2 name, and my distance all as public things here. So I can go ahead and extract them. Okay, so we parsed it. Now we need to get the towns given their names. So town pointer T1 is equal to something. Town pointer T2 is equal to something. Who knows how to give me a town given a string? And that something is going to be something like the parts dot town 1. That is what I called it, right? That's parts. Town 1 name is what I called it. And the parts dot town 2 name. So these guys are strings. I need to convert that string into an actual town. Who knows how to do that? We wrote the ability at the end of class last time into town collection, something called get town, that takes in a string and spits out a town, which means that this function get roads needs to know about my town collection. When I call get roads, I need to pass it the town collection so that he's able to search that collection for the roads that or for the towns given the town names. So I can say TC get town, passing it town one's name, TC get town, passing it town two's name. This will return a pointer to those towns. All right, so now I'm going to have a road. So I'll create a road pointer. R is equal to a new, just remind ourselves for road. A road takes in a town pointer, and a distance. So I just found my first town pointer. I just found my second town pointer using my town collection to look up the town pointer given the town name. Now I can extract the distance from my parts. Because my road parts has a public variable called distance. This is going to be a new road, passing it T1, T2, and the parts dot distance. So those are the pieces of information I need for a road. And then what am I going to do with that road? I'm going to add it to my collection of roads at bucket pause, my road R. Now, if I want to match this up to what I did earlier, I didn't just keep creating this variable again every single time. I actually defined it up here. Didn't I define it up there? Oh, maybe I didn't. Maybe I did put it down here. It's fine. All right. So store that collection of roads, or store in collection of roads the road I just built after I looked up the two town names inside of my town collection to get the actual towns, and then increment pause. All right. If I had just finished counting, if I was still the first time through, I need to go ahead and build a road pointer. So give me enough memory to hold this many roads. That's what I'm ultimately building in my collection of roads. Otherwise, in my road collection, I'm going to build a new road collection, passing it my collection of roads and my count. In the end, I'll return my road collection. Make sure I called it RC there. Here's my constructor for road collection is my collection of roads, and then the count. All right, so that looks reasonable. All right, so get roads is going to require a town collection to work. So that's a little bit different than get towns before. I'll go through the whole file, roads.txt. First time through counting the number of elements. Second time through parsing my road into parts, finding the actual town pointers given their names, building a new instance of road given those two town pointers and the distance, add it to my collection of roads, and then move on to the next one that I need to add to that collection. Last time through, if this was my last time through the loop, actually build my instance of road collection, passing it my now filled array along with how many elements are in it, and return that guy. Now up here in main, the stuff here was all proving that I had the towns. Now I'm going to have a road collection pointer, RC, is equal to get roads, passing it that town collection. Because my get roads function that I just wrote, this guy needs a town collection to work. I'm lost. I'm still lost. Where's main? Okay. And then we want to prove that this guy is working. So we'll say for int I is equal to 0, I is less than RC count, I plus plus. I did make those public, right, for my road collection. Yeah, they're all public. And then I'll go ahead and say RC the roads at bucket I display, because a road does not know how to display itself. That's okay. We probably need to teach it to display itself then. So we're going to write display in for a road, just to have it have some sort of output to the screen. All right, let me go ahead and hit save here real quick. So for a road to display itself, we probably want to do something like, let me make sure I have IO stream there. So maybe have the first town name, the second town name, and then the distance, something like that. I don't know, just proving that we got the information. Doesn't have to be anything fancy. So this T1, what's the town's town name is private, and we have a get town name from that guy. So that'll be the town name of T1. And then we'll have, you know, something like a couple of lines. That's the road. This T2. Get town name. And then we'll just put a colon followed by the distance. This distance. All right, so for a road to display itself, we'll show the first town name, we'll show a little line, then the second town name, then a colon, and then the distance between those two. That's what we decided that a road looks like if we were to display it to the screen. Back here in main, we're going to go through all of our roads in our road collection. So I0, I is less than row collection, RC.count. get the roads, that's my actual array at bucket I, and tell that particular road to display itself. All right, that should show all of these roads in a similar format to this with just some dashes in here, but knowing that we had converted from a string to an actual town and then asked that town what its name was as a string. So we do actually have it as a town, and we will be able to prove that here in a second once we see this guy working. Get roads was not disclosed. Oh, did I not prototype it? I didn't. I just copied and pasted it. So this guy right here, I need to make sure I prototype up top. This is a dot issue. Have an arrow. So this is an incomplete. This T1 is a town pointer. I'm asking that guy to get the town name, and that is part of town, right? Get town name. Okay. Let's look at that error one more time here. So that same problem we had a couple of classes ago where it didn't know about the class town. Incomplete type town. Road HPP. Yeah, I defined town in here. Well, just for the sake of argument for a moment, before I go and debug that, just make sure we have pointers for our two towns. Okay, so this is a town, this is a town. Our third one down, I must have a spelling error, third and fourth and sixth. The second road, Port Washington. Okay, I must not have called it the same name in this guy. Nope. Make sure our names are spelled the same. Okay. So now we should get pointers everywhere. Do I need to save this? Oh, hold on. I'm telling it to ignore spaces right now. So this guy's a problem. Yeah. Easy peasy. All right, no longer a problem. If you remember correctly from last class, Just so I didn't have to go and backspace these spaces out from the commas. I told our code that parses roads to, oh, just ignore spaces. Well, that means it also ignored the space under Port Washington. So it was no longer a two-word thing like in the original. So we'll just say this is fine. Okay, so then that's definitely, I mean, right now we're proving we got the all the roads. The roads are created. Let's go find out why we didn't have our city names showing up. So that guy is a town. Let's just do it for 1/2 of it. Yeah, invalid use of incomplete type class town. So it doesn't like me calling a town name, this function, on something that we're back to that problem from a couple of classes ago. I prototype town here. I said, road, you know about town because he looks like this. See, that really is kind of terrible. So that means that I need to let's see if this fixes it. He just needs to know that much about town. Okay, yeah, it doesn't like me redefining class town, so that's, I would have expected that to be what it's complaining about here is I've prototyped town and it's saying, oh, well, this town, this class is incomplete at this point in time. When I'm actually implementing display for my road, this guy right here, this is really showing us some of the perks of a newer language like Java, where it's cleared a lot of these things up. So right here, it's cool with me saying this T1. We saw that a few minutes ago. No problem. I got a pointer to a town. You want to use that pointer later on, have at it. But since I'm now taking that pointer, I'm trying to resolve it to it. So let me just make sure real quick. Yeah, those are town pointers. I'm trying to call a function that lives inside of there. It's saying, wait a minute. You are trying to call a function on a town that is not on a class that is currently incomplete. All you've told me about that guy is this. All you've told me about him is that there will be a class called town. You haven't told me any other information about it, including that I'm going to find a function in there called get town name. So I suppose I can do something like get town name returns a string. Say that that guy will exist. Well, that's not how we could make it attach. Just for a second, I'm going to move the two towns to public. And rather than calling display on those, print out the first town name. See if he's cool with that. Oh, it's still no, it doesn't like the syntax I have in. I'll just comment out the display. I'll pretend like I didn't write that since I'm trying to write it externally. Yeah, so it's cool. Oh, just 6. Oh, that's interesting. That is a town. Oh, I'm still printing out this stuff up here. That was like, what's printing out there? There's my road collection. So that should be a, oh, I'm not outing that. That's why nothing's popping out. Make sure that that's a town. Make sure I have my 2 pieces. Pretty positive I do at this point. I'm able to extract 2 separate towns from each of these. So it's the town 1, town 2. Those are 2 separate addresses. So I'm going to ask this guy. Town. Just for the sake of argument here, because the issue seems to be with calling the functions. Yeah, see, I can get to the town name there. Presumably, I'll be able to get to the town name here. Yeah, so those are all good. So then if I go into this guy and I go to display, I just call town name on that. Yeah, it still doesn't like me using that town. So I proved I can get to it externally, but I can't ask a town. I'm sorry, I can't ask a road to display itself because it doesn't have enough information about town in order to start calling crap on town. So where's my road? So that's where we're back to that thing I was trying to tell you about, that class, that if not defined. You know, because if I put in include town HPP here, yeah, see, now it's cool with it. But the issue is it happens to work in this case because I tested it out to see where the problem was. Oh, yeah. So just got a note. So the issue is this. We knew that the problem was it doesn't know about town HPP. And Alex is the one who sent me the note. I don't know if you could see it when I pop up chat on here. I think it hides it when from a screen share. And let me kind of backtrack and do it the other way. So if I go into road, let's see. So I'm in town HPP. So if I go into town CPP and I include road HPP, I think this is where we got that infinite loop thing. Oh, I need to put the other thing back in there. This was from several classes ago. Well, if that's the case, oh wait, was it this? We may have just answered the question from 2 classes ago or 3 classes ago, whatever it was. Can't I do this here? And for town, can't I do that there? Yeah, see, this is where we get our infinite loop. Okay, so we could, okay, this is the full explanation for it then. Interesting. So I mentioned a couple of classes ago, we're at the kind of the mercy of which version of C++, which vintage of C++ these are calling from. This is a modern 2-pass compiler version, but this is very related. So I could say I did this on purpose, even though I didn't. This is very related to why we never had those problems in here when we were defining some of these smaller classes just at the top of main. And that sort of kind of got out of hand, you know, where we probably should have separated these, but we didn't. But the idea here is that when I'm building my header file in here for town, I just need to prototype my class road so that this line right here is cool. It knows that this dude will exist. But in the actual implementation, when I might need the full forced road, in this particular case, I don't. I'm not actually using details about road inside of here, but when I might need it, I should have full access to that guy there. Now, Where we actually see this come into play is on the road side of things. So I'm going to say, look, I have a couple of towns here, so you need to know about towns so that this compiles. But in the actual road implementation, you're doing some stuff related to towns here, which means you actually need to know about town. This is the complete definition of town. That's what it was complaining about before. In town. Oh, because class road, this guy, define town. Oh, it's, I need to take that out of there. And I should have it in road CPP. Yeah. So just to reiterate that in our last couple minutes here, in the header file, so this has a difference with how the compiler handles header files and how it handles implementation files. Now, having said that, I think whether it was last class or the class before, I made the comment about, can you make the argument of not using header files anymore? Since like a language like Java, for example, your classes all exist inside of a single file. There isn't a separation between the implementation and the documentation, the header file portion of it. But the way header files are processed is, in order for this header file to compile, since it uses a road pointer, you have to at least promise, this is like a prototype of that guy. And road's the better example here. So same thing with the road header. Since I'm going to have a couple of towns here, I needed to prototype that that's a thing. I mean, that's a promise I'm making that that's a thing. But in road CPP, where I actually use towns, I'm actually calling upon things on towns. Now he needs to know actual stuff about towns. So I had to give him the complete definition of a town, not just that prototype definition. And it's because of how the linker works. The header file was used for the first pass of compilation. But then when you actually try to create your executables out of it, executing the CPP files, or the compiling the CPP files, that's when it actually needs to know about the inner workings of town. So if I go back into town HPP and I move town name back to private where we probably want it. Now I should be able to call upon my get town name inside of here. He has the full definition of what a town is now. So there's our output for our roads, which is a road proving that it has access to those two towns. Well, this guy doesn't have the arrows to like shrink stuff down, so I kind of just go down to main. All right, so this main looks a little bit, well, the main CPP files get a little bit messy because of these tools. I probably could make an argument that I should suck those into a class somewhere. So this guy's a little bit messy, but if we only look at main here, let me just get rid of all of our old commented out stuff. I only look at main here. Main's pretty short and sweet. Get my town collection from my towns text file. Get my road collection, my roads text file. I proved that the roads work, but this isn't really a necessity for this thing. So really at the end of these two files, my road collection holds my graph. So my graph is stored in this array called the roads of my road collection, where there is RC count number of those guys. And that's what your graph is. It's that collection of roads. The problem we have right now, well, it's not really a problem. It's like, okay, well, how do I use a graph? So what I'm telling you right now is this guy is our graph. He actually holds all the data of our graph that links all these different actual towns together via roads. This guy holds how many of those there are. So that's our data type that we created to hold two pieces of information about that, since arrays can't hold their count themselves. All right. So, but this guy in and of itself, that's our actual graph. Now, the thing is that when we think about, and this is just kind of pushing us to where we'll start next week, when we think about that traveling salesman problem, the concept, or any mapping problem, the concept is, okay, well, I have a starting town. Wherever I live, that's my starting town. So that would be the entry point into the graph where you would start. So you might go through and say, okay, well, I need to check my collection of roads and go and find the town in there where I live. And from that, I can get, start taking roads that lead to other places. All right. And why is that? It's because a road knows how it links to other towns. A town itself does not know about the roads that come out of it. We could expand this, and as we are building these guys, when a town gets added to a when a town gets added to a road, that road then lets the town know that, hey, I am a road that leaves you. So you could have something in here that says maybe a town has a collection of roads that go to and from that town. So I could then ask a town what roads are possible to take from you. That actually would be somewhat handy to have for the traveling salesman problem. So what I'll just do is make a little note here. We'll add that starting next class. Each town's how to know about the roads they are involved in. All right, questions, comments, concerns, bribes. All right, everybody have a safe and healthy Thanksgiving. No homework over break, so I will see us all back in class on Monday.